In the previous tutorial, I talked about portfolio variance for a two-security portfolio. And here I want to do a numerical example. And I've already written out the problem here. We have three states of the world. We have two securities, A and B. And we have probabilities assigned to each state of the world. Those probabilities come from our economic forecasters. And we forecasted that there's a 25% chance of recession, a 50% chance of normal growth, and a 25% chance of a boom period. And if we're in a recession, A stock will return 4%, normal economic growth 10%, and a boom period 16%. And then likewise, you can read the numbers for B. The first thing we need to do is we need to work out the expected returns for each one of these securities, and I've already done that. The expected return for A, it's just a weighted average, 25% chance of a recession times the return that A gets in the recession plus 50% chance that we're normal growth times the return that A gets in normal growth, etc. And it works out to be 10%. And you can check these numbers yourself. And I did the same for B. Okay, so we have the expected return for both. Let's look at the expected return for the portfolio. Up here I've said that the weight in the portfolio in this example is 40% in stock A, 60% in stock B. So let's work that out. The expected return for the portfolio is going to be equal to 0.40, 40% chance that we're of A times the expected return for A, which is 10%, plus a 60% chance, or 60% weighting, which is not really chance, it's weighting, 40% weight on the 10%, 60% weight on the 7%. And if we work that out, let's see, 0.6 times 7 is 4.2, 0.4 of 10 is 4, so 8.2%. So the expected return for our portfolio is 8.2%. And again, make sure it makes sense. It should be between the 7 and the 10, which it is, and so that's a reasonable number. All too often, students will just accept a number and say, well, that's what I calculated, that's what my calculator spit out, must be right. Well, you could have typed in something wrong, or your calculator could have been set incorrectly. All right, the second thing we need to do is we need to calculate the variance for each one of these securities. So for A, it's going to be, and we'll use the notation sigma squared A, it's going to be probability we're in the first state of the world times the return that we get for A in the first state minus its average value squared plus the probability we're in the second state of the world, sorry, that's 50%, times its average value minus, its value in that state of the world minus its average value squared plus the probability we're in the third state of the world, okay, the boom period, and the return we get there is 16 minus 10, and make sure you square it. And so what do we have here? Well, this is going to disappear because 10 minus 10 is 0, and 4 minus 10 is 6, minus 6, and if we square it, that's 36. Over here, this is also 6 squared, 36. So we're going to have 0.25. We're going to have two of these. We're going to have 0.5 times 36. So that's going to be 18. Okay, and let's do it for B. For B, same thing, follow the same formula. Sigma squared B is going to be equal to 40% chance we're in the first state of the world. In the first state of the world, we get a 9% return minus its expected value squared. I'm sorry, that's not 40%, that's 25%. So let me erase that. Hold on for a second. Okay, got to be careful. You got a lot of probabilities here, and it's easy to sort of get caught up. The 40% has to do with the weighting for the amount that's in stock A, but that's not what we want. So we want 25% here. It's a 25% chance that we're in a recession, and if we're in a recession, B returns 9% minus its average value, plus there's a 50% chance we have normal growth, and during normal growth it returns 7, but its average value is also 7 squared. And then in the final state of the world, the boom period, 25% chance, and it's 5 minus 7 squared. All right, so what do we have here? Again, this is going to cancel. 7 minus 7 is 0, so we just have 9 minus 7 is 2, squared is 4. This is minus 2, squared would be positive 4, so you're going to have 0.5 times 4, or you're going to have 2. Okay, we also need the covariance between A and B. And so let's work that one out. The covariance between A and B, denoted by sigma AB, is going to be the probability we're in the first state of the world, and then you're going to take the value of A in the first state minus its average value times the value for B in that state of the world minus its average value, plus 50% chance that we have normal growth, and you're going to have 10 minus 10 and 7 minus 7 plus a 25% chance. Sort of running out of space here. Hope I can squeeze it in. And we're going to have 16 minus 10 times 5 minus 7. All right, that's a parenthesis around there. So let's see, this middle term drops out, right? 10 minus 10, 7 minus 7 are 0, if either one of those were 0. So what do we have here? We have minus 6 times positive 2. So this is going to be equal to 0.25 minus 6 times positive 2 is minus 12. And then plus 0.25 positive 6 times negative 2 is also minus 12. Minus 12. So what do I have here? I have 0.5 times minus 12. So I have minus 6, I believe. All right, so now we can calculate the portfolio variance. The portfolio variance is going to be equal to, the formula is WA squared times the variance of A plus the percentage we put in B squared times the variance of B plus 2 times WA times WB times the covariance between A and B. So let's plug in here. It's 0.4 times, and what was the variance of A? The variance of A was 18. Plus I'm sorry, I forgot to square this term. Okay, be really careful. 0.6 squared times the variance of B, which happens to be 2, plus 2 times 0.4 times 0.6 times the covariance between A and B, which is minus 6. Okay, without even doing it, you see, we've got a negative number. We're going to be subtracting this out. This is going to reduce our risk. All right, so let's see what we have here. We have 0.4 squared, 0.16, times 18. So the first term is 2.88 plus 0.6 squared times 2.72 plus 2 times 0.4 times 0.6 times -6, so this is minus 2.88. Oh, I didn't really plan for it to come out that way. These two numbers are going to cancel each other, so we get a portfolio variance of 0.72. Gee, look at that. That's really nice. What do you notice? Let's look at this. Let's go back. All right. Let me write what we came up with here. We came up with an expected return for the portfolio of 8.2, and we came up with a portfolio variance of 0.72. And let's look. This portfolio is going to have a higher expected return than B, right? B had only a 7% return, but B had a variance of 2. And this has a portfolio variance of 0.72. So by combining A and B, and they're both risky assets, we actually increased our return by 1.2%, and we reduced our variance by, what, 1.28? So you can see that adding A to B turned out to be better than just having B by itself. It was actually less risky. And if you look at this, if you look at these numbers, okay, you can see that they have a negative covariance or a negative correlation. In fact, they have, if you work it out, they have a correlation of -1. In fact, we can do that in 1 second. But notice how when this one's going up, this one's going down. This is going up, this is going down. They're moving in opposite directions. It's negatively related, negative covariance or negative correlation. Let's work out the correlation coefficient as long as I did that. Okay, the correlation coefficient between A and B is equal to the covariance of A and B, okay, over the standard deviation of A divided by the standard deviation of B. I should have put sigma AB, that's what I've been using. Okay, the covariance was -6. What was the variance of A was 18, I believe, right? Let's just go back and check. Was 18, and the variance for B was 2. So we're going to have square root of 18 times the square root of 2. And this hopefully will work out to be -1. Let's see. If we take 18 and we take the square root, I'm going to store that in 1. And then I take 2 and I take the square root of that and I multiply it by that first number. I get 6. So I get -6 over 6. The 6's cancel. We get -1. So we've actually worked out sort of a whole expected return, expected portfolio return, expected variance. We've computed covariance and correlation. So you've sort of seen it all done here in one example.